So we need to be able to draw Lewis structures for molecular compounds. We did an illustration with the ionic compound, and it's helpful, but we don't generally write or draw Lewis structures for ionic compounds. But we do need to be able to do them for molecular compounds and for the polyatomic ions, because polyatomic ions are held together by covalent bonds. So this is a process that can be approached in different ways. Pretty sure this is the same approach that the book has. So maybe start with this, and then if you find a way that works better for you, as long as you end up with the same result, it's fine. So the first thing we have to do is have the correct skeletal structure of the molecule. That means we have to decide which different elements are connected to each other. And when we're doing this, we need to remember to always put the hydrogen atoms as terminal atoms. What does that mean? They're at the end. Hydrogen only makes one bond. It cannot be between two oxygen atoms because it only has one electron. It can't bond with more than one atom. So the hydrogen atoms are always going to be on the outside. And another guideline is to put more electronegative atoms in the terminal positions. In the next section, we're going to learn about something called formal charge that will help us to make some of the decisions that these rules don't solve for us, but we'll save that for Wednesday. Then we want to figure out the total number of electrons for the Lewis structure, and we do that by counting up all the valence electrons for all the atoms in the molecule. And then if we have ions, we have to take into account the charge. So if you have a -3 ion, that means you have to add in 3 electrons. If you have a +2 ion, you have to subtract 2 electrons. And those are your dots. Yes?
I think you remember when element becomes under more than 8 electrons, like, doesn't go over the octet rule.
How do you decide when an atom can go over the octet rule? We will get to that. For now, we're going to ignore that. But yes, we will talk about it. So once you have your arrangement and your number of dots, you're going to distribute the electrons, the dots, among the atoms, trying to make everybody happy. Everybody wants 8 dots, except for hydrogen, he just wants 2. But you spread the dots around and see if you can make everybody happy. Sometimes you don't have enough dots, you don't have enough electrons. That means there's more sharing that's required. And so then make double or triple bonds as needed. So we'll do a couple of examples. So let's look at carbon monoxide. So the first thing is to decide, well, how are these atoms connected? Well, there's only 2 of them, right? So there's really only one possibility, that carbon must be connected to the oxygen. How many valence electrons do we have for the 2 atoms? How many does carbon have? 4, and oxygen has 6. So we have a total of 10 valence electrons. That means we can put 10 dots around. We have to have at least a single bond between every atom. Otherwise, they're not going to stick together. So I'm going to make a bond between the carbon and the oxygen. So there's 2 of my dots. And then I'll start trying to make octets. There's 2, 4, 6, 8, 10. I'm out of electrons, out of dots. Is everybody happy? No? Carbon's happy. Is oxygen happy? No, oxygen is really not happy. He's like, dude, this is not fair. You've got 8 and I've got 4. What's up with this? You need to share with me. So carbon's going to take this lone pair and say, oh, okay, calm down. We'll share these electrons. I'm going to move those, and I'm going to stick them over here. I didn't add any electrons. I still have 10. 2, 4, 6, 8, 10. Is this better? It's better, but oxygen's still not happy. Carbon has 2 lone pairs here. We could take one of these and move it in there. Doesn't matter which one you move. So we'll do another one in there. Still have 10 electrons total. But we're sharing 3 pairs. We made a triple bond. Now is everybody happy?
Smashing.
Yeah, they're smashing happy. They're just saucy. Phew, we figured it out. A lot of times when you draw your Lewis structure, you kind of make a mess, and it's kind of awkward looking. So then it's often nice to just copy it down neatly. So I'm going to make my 3 bonds there. Here's my oxygen, and I like to make things symmetrical, and I'll put my lone pairs on the outside ends. So there's my Lewis structure for carbon monoxide. Any questions? Okay, H2CO. Well, the hydrogens have to be on the outside. So we're going to start with carbon and oxygen being bonded to each other. And then we're going to have to figure out where to put the hydrogens. So, well, let's put a hydrogen here and a hydrogen there. Just kind of be symmetrical and see what happens. How many valence electrons? Well, we've got 2 hydrogens, and they each have how many valence electrons? 1. And the carbon has how many? 4. And the oxygen has 6. So this time we have 12 dots to mess around with. So let's make some bonds. So there's 2, 4, 6 electrons. I've got 6 more. 2, 4, 6, 8, 10, 12. I'm short again. We need a double bond. I don't want to take this lone pair, because if I stick this one in here, then oxygen's going to have too many. The oxygen's happy, so the oxygen's going to take one of his lone pairs and share it with the carbon. I'm going to take this guy down here and put it in here and share like that. So carbon has 2, 4, 6, 8. Oxygen has 2, 4, 6, 8. Each of the hydrogens has 2. They're happy. Now, is that the only way you could draw that? No, it's not. You could also draw it with both of the hydrogens on the carbon. And you can also make them all happy that way. How do you decide which is better? Well, that's where formal charges help us. But we'll learn about those on Wednesday. Any questions? Let's do an ion. What's the name of that ion? Hypochlorite. Just a little review there. Okay, so again, this is another diatomic molecule, so it's not too hard to figure out how they're connected. The chlorine and the oxygen have to be connected to each other. How many valence electrons does chlorine have? 7. How many does oxygen have? 6. The -1 charge, do we add 1 or subtract 1? Add 1. We're adding negative electrons. So we've got 14. Start with the bond. Got to have at least a single bond. So that's 2, 4, 6, 8, 10, 12, 14. Hey, worked out that time. Don't need any multiple bonds. This is an ion, though, so I should put brackets around it and put the charge on it, because otherwise somebody's going to look at that and say, you got too many electrons on there. Any questions?